This is going to be part 3 of the XFOIL assignment. In this assignment, we are going to be comparing the Clark-Y airfoil with different angles of its flap at 15 degrees and 25 degrees and with 0 degrees of flap. So we already have the data for the 0 degrees of flap, or the 0 degrees no flap, I guess. That was done in the previous video. Actually, it was part 1, I believe, where we just did the Reynolds number was 3 million, and we just used the Clark-Y airfoil. So for the first case with the 15 degrees, all I'm going to do is I'm going to load up, actually let me quit this really quick and then reload it. I'm going to load the Clark-Y data, and then we're going to click pane to change our panel nodes to 160. Then we can go to geometric design, GDES, open up this here. Now we want our flap to occur at 0.7, and we want the flap to be hinged around the center point of this. So if I go down here, we can type F for flap. We can do 0.7 for our X location, 999 to specify that we want to put it around half of the Y location, and flap deflection will be 15. And we can actually see that right here. It gets deflected down 15 degrees. So once this is complete, we need to save our data in this XFOIL. So we're going to click exec or execute, and it saves it. And then we can click enter again, and we wanted to go to opera this time, change it to viscous flow, change it to 3 million. And then I would do PACC, which would save my file or all the data into a file, but that has already been done. So I'm just going to quickly show you the interval from -5 to 15 to 1, and we'll click enter. And yeah, we got our convergence. So I will quickly move over to the files that I actually got from this, which is here. And then we need to go to desktop, Fluent, part 3 data. Open that up really quick. And so our 15 degree flap is here. This is our data that we essentially got from that, that 15 degree flap I just did a second ago. And if we compare our answers, let me actually get rid of this really quick. Open up this, not this. Never mind, it didn't show up. But essentially, this is the data that I did get from that. And then next, I'll show you how to do the 25 degree one. So to do that, all you have to do is go back to here. We're going to quit out of here, reopen it, go to load, pane, geometric design. Same steps as before, but now we're doing 25 degrees. So F for flap, 0.7 along the x-axis, and at half. We're going to pivot around the halfway point, and 25 degree deflection downwards. Exec saves everything going on. Now we can go to opera, viscous, 3e to the 6, and PACC if we wanted to save a file, but again, I've already got the data, so I'm just going to show you how I obtained it, a sequence, and we're going to go -5, 15, 1, and enter. Now, because this didn't converge, I can actually change our iterations to 500, and I'm going to redo that again. So it'll take a little bit longer to converge, but we will get convergence if we extend our iterations long enough. Perfect, we got our convergence. And again, we're just going to check this. So our alpha here is 15, and our lift coefficient is 1.9922. I will check the data very quickly to show that that's accurate. 1.9922 for 15 degrees. Again, it didn't pop up on the screen, but this is the data I did collect, and it is all saved into here. And if you're wondering where this data got saved, it's saved into, where is it? XFOIL. This was saved under Clark 15. This is the 25 degree one here. I'll just open that really quickly on Word. we have this here. As you can see, we are missing a couple values from the top. We have -5 down here. You kind of have to work with it. If it doesn't converge everywhere, you have to kind of do it in pieces in order for it to, and then you can combine all your results at the end, which is essentially what I had to do here. So we'll exit out of that, exit out of that. Perfect, I'll minimize that. And then I'll just, I guess, show the results total. This is the no flap condition, which essentially is just the Clark-White airfoil, literally just with no flaps, which we got in part 1. So I'm just reusing this data. And all these graphs are just comparing these 3 different scenarios. So the first one here, we have the 0-degree flap, 15-degree flap, and 25-degree flap. And as you can see, it kind of varies. This is the angle of attack versus lift coefficient. This is the angle of attack versus drag coefficient, and this is the angle of attack versus our lift to drag ratio. And you can see we do get a little bit of a trend, so we do have a little bit of an outlier kind of area here, or that's what it looks like compared to the rest of the graph, similar to an outlier we had in part 2 with our laminar flow. But you know, it's XFOIL, we can't do too much about that. We need our general trends, and that's basically what we have from here. So on that, I believe that concludes the part 3 tutorial. If I decide to do the bonus, I will upload the part 4 bonus tutorial after this video. And thank you for watching.